Suppose x is gamma 1 meter, y is gamma 1 meter as well. U is x plus y, and we want to find the density of U. Going to write the density of x first. We know for a gamma distribution, the density is that. Yes. Plug in 1, so 1 over beta raised 1 for alpha, gamma of 1, x raised 1 minus 1, e raised minus x over beta. Gamma of 1 is 1. Reason being, gamma of n is n minus 1 factorial for any integer. So if I plug in 1, 1 minus 1 is 0, 0 factorial is 1. So 1 over beta, gamma of 1 is 1. X raised 1 minus 1 would be x raised 0, which is 1. I end up having e raised x over beta. Does that remind you of the density of some random variable? That is an exponential random variable. If you recall, our exponential that we talked about was exponential lambda, correct? And in this case, lambda is just 1 over beta. And the density of an exponential matches that. Good. So by all means, x is exponential. Lambda is just 1 over beta. We used lambda, which is why I'm sticking with lambda. But in terms of gamma, it is what lambda is 1 over beta. Now, I know the convolution integral. It simply states, take fx, evaluate as b. Fy, evaluate it at u minus v, and integrate it over v. That's what we derived for the sum of random variables. And that simply is the convolution integral. Going back to what I have here, have 1 over beta e raised minus x over beta multiplied by 1 over beta e raised minus u minus v over beta dv. Good. So I'll have 1 over beta squared and integral 0 to infinity e raised minus v over beta times e raised minus u over beta times e raised plus v over beta. Just split this up. E raised minus u over beta multiplied by e raised v over beta times dv. Good. What happens to e raised minus v over beta and e raised plus v over beta? Those two would go away. So I end up having 1 over beta squared integral 0 to infinity e raised minus u over beta dv. Would that affect, would the integral affect that term, e raised minus u over beta? No. And you may look at that integral and say, well, integrating dv from 0 to infinity will end up having infinity as the answer. That is not true. Why? So I did all this work, ended up getting this. Integral of dv is v. Plug in the upper limit, infinity. Lower limit, 0. Somebody do symmetry? Not symmetry. Is there a boundary? Is there a bound? Is there a bound? Oh, that integral could only exist under one condition. Sure, v can go from 0 to infinity, but u minus v cannot be negative, right? Because fy is an exponential and the support is from 0 to infinity. If you put a negative number, the entire integral will become 0. Do you agree? So the requirement here is u minus v has to be bigger than 0. Because of the fact that the support of y is 0 to infinity. That would simply imply u minus v is greater than 0. U is greater than v, which would mean v is less than u. And me. So instead of 0 to infinity, it is 0 to u because v has to be less than u. Once I integrate, I will get fu of u to be 1 over beta squared e raised minus u over beta multiplied by u. Correct. So 1 over beta squared. I'm going to throw in some stuff here. Gamma of 2. Gamma of 2 is 1 factorial. 1 is just 1. So I just replace 1 here by gamma of 2. Yes? Move that u. The power here is 1, so I can write it as 2 minus 1. Agreed. I didn't do anything wrong. All I did is rewrite 1. And I know, since x is from 0 to infinity, y 0 to infinity, the support of u is 0 to infinity. Good. Can you identify that distribution? No. The 2 beta. So the sum of 2 i.i.d. gamma 1 beta variant is gamma 2 beta. Another way to look at it, if you add 2 exponentials, you will get gamma 2 beta. If you have to take a guess, if I add n i.i.d. exponentials with parameter 1 over beta, what would I get? The sum will have gamma n comma beta. Does that make sense? You may say, well, practically, what is the use? Well, on the exam, there was a Salmon problem, right? And I discussed about a lifetime problem. Let's say you buy a case of light bulbs and you want to know the chances that the sum of their lifetimes is some value, right? We did a problem on minimum, we did a problem on maximum. In a similar manner, we could do one on the sum, provided we can come up with a closed form expression. If we know this, then all I have to do, plug it in the formula. Does that make sense? And of course, there are cases in practice where you simply cannot come up with a density. In those cases, we will need a simulation.